Our next presentation is TDS in the Republic of Korea, Progress in Last 2 Decades and a Way Forward. It's by Dr. Cho-il Kim. And Dr. Kim has quite a record of achievement. She's a PhD in nutritional sciences. And since 1991, she's worked at the Department of Health Industry and Policy of Food and Nutrition Industry, and eventually becoming executive director of the Korea Health Industry Development Institute. Proceed.
Thank you for a kind introduction. First of all, I'd like to thank BFR for giving me a chance to introduce you about the total diet study in Korea. As the chairperson introduced me, I am a nutrition person, so I am very much interested in explaining what kind of dietary intake data we have just to work with total diet study. Anyway, I guess I'm pushing the right button. Okay. As you may know already, we had huge total population growth during the last 5 decades in Korea. Starting from 1970 to 2000, or during 30 years, we had 50% increase in population, which is quite huge, I believe. And during the same time, what we had was a real leap in GNI per capita during the same period. Starting from 240 USD, it has ended at 34,000 USD in 2019. So this kind of change, or whatever you call, made a big difference in diet, of course. In addition to that, what we saw was that there was a really drop in farm population in Korea. From 1970 to 2000, it was only it went down to the 1/4 of the usual value, and then by 2020, it was 1/5 of the 1970 values, meaning that very small portion of the Korean population is working on agricultural business, and they are responsible for producing all the foods we eat, meaning that we have very, very low self-sufficiency rate for food supply. As I explained, because of the economic change and population growth and farm population, etc., we had a big change in diet during the same period, resulting in a huge increase in fat intake in terms of energy ratio. So you can imagine what kind of food we are eating compared to 1970. Because of this huge difference in diet or huge change in diet, the Korean government got interested in looking into the diet. They thought they need to look into the total diet. So as I highlighted in the right column, in 1994, there was a pilot study on total diet study. Is a pilot study type study. It was conducted for total diet study. And then, as you can see here, heavy metals and metals were kind of most common analyzed for Korean total diet study. But these total diet studies were not continuous one. It was intermittent one. Sometimes it goes in small scale, or sometimes it was conducted for a larger scale, etc. Mostly as a research developed R&D project. And mycotoxins and pesticides were, I guess, they were analyzed maybe a couple of times only during the last 2 decades. And PCBs and processing and cooking contaminants were analyzed more recently. By 1995, the National Health Promotion Act was enacted, and with that act, the Korean government was able to secure a very detailed dietary intake data, including health exam data. So it started with the Korean National Health and Nutrition Examination Survey, started as a triennial survey in 1998 for the first time, including health exam of individuals and dietary intake, very detailed food intake data of individuals, covering about 10,000 individuals in 1998, but now by 2020, 2021, we have only 7,000 individuals data in these days every year. With that Korean National Health and Nutrition Survey in place, these are the national food intake data available as of 2022, July 2022 actually. The Korean National Health and Nutrition Examination Survey is the major source. The first three, 1998, 2001, and 2005, they were conducted triennially. So there were not that many individuals, about 10,000 individuals only for that each 3-year period. But from 2007 and on, it became a year-round survey, meaning that each year about 7,000 individuals for the intake data are available. And the second KNH seasonal nutrition survey was meant to complement the first, second, and the third KNH because they were conducted in the winter during November and December in each year. So that's why we had seasonal survey, but from 2007 and on, we didn't need to have the seasonal survey anymore. And number 3 and 4 were kind of a special dietary intake survey conducted by Korea Food and Drug Administration just to complement the lack of data of specific age groups such as infants, pregnant women, and lactating women, and general children. And this is showing the same thing I just showed through the other table. The heavy metals is the kind of common denominator, but as you can see here, the TDS was done intermittently with different scale. And by 2011, the Korean government, at the time it was KFDA, was barged to establish a TDS master plan. And according to the TDS plan, they started to expand the analytes, and also they started to expand the food list. And this 2011 master plan was planned this way very ambitiously for the first feasibility testing stage for 3 years, and second stabilization stage, and third customization and communication stage. During the first feasibility testing stage, we have worked on the methodology and concepts and etc. to have a kind of official set of total diet study in terms of Korean government. And during the second stabilization stage, we worked on methodology to expand analytes, and then analytical methodology. And then during the third stage, just before the third stage, the government was able to make a legal basis for the Korean total diet study. I know that in the morning session, someone asked how the budgets were secured or etc. And because of that budget problem, that was the reason why the total diet study in Korea was conducted intermittently, not continuously before. That's why the Ministry of Food and Drug Safety tried to work hard on just making it on the act to be sure that they can get enough budget every year. So they succeeded in making the total diet study as a legal base on 2014. And the third customization and communication stage, during that period, we have started the first official legally based Korean total diet study for the first time for the 5-year term. And by 2012, we introduced the mapping for close to real estimate because the Korean government was not comfortable with the fact that every total diet study so far conducted was dealing with about 100 food items or less, meaning that about 1,000 food items are left behind, depending on the food intake data of the KNHs. So that's why we tried to introduce mapping based on the systematic similarity between similar foods which belong to the same group. And we found that about 20-30% increase we've seen in terms of exposure or intake, etc. And there was a total diet study as one of the huge kind of larger R&D project from 2013 to 2016 for a 3-year period. As you can see here, we had enough time to work on crops and products, meats and products, and seafood and products separately each year. So we were able to deal with processing and cooking contaminants for the first time, and there were like 40 different kind of contaminants handled. And this was done in 3 rounds in 3-year cycle. First, every year we had to spend some time for tedious planning for that year, and then the second stage was implementation, meaning food purchase, collection, preparation, and analysis. And the third was exposure and assessment period, and then fourth, last one was report and announcement of the result for each 3 years. A couple of the interesting results from this R&D type study was that we found a huge change in terms of acrylamide content in black peppers by cooking and processing. So the government made a campaign at the time based on that result that you better know the right time to sprinkle pepper on your food, something like that. So if you sprinkle the pepper after cooking, after the cooking is completed, you can just have a tasty meal. But if you sprinkle black peppers before cooking and you cook with black peppers, you're going to have a huge amount of acrylamide in your diet. That's what we had. And another interesting one was we had very high level of furan in coffee, especially coffee extracted in espresso type coffee in most of the cafes are serving. On the other hand, those drip style coffee or brewing coffee didn't have furan at all. So if you love flavor, you go with just espresso type extraction and go with furan. But if you're not much on flavor, you better drink drip style coffee for your health. That's what we were saying at the time. Anyway, by 2014, the Korean government Ministry of Food and Drug Safety was able to succeed in making legal basis, putting total diet study 3 words in the Food Sanitation Act through amendment. It mentioned about the management plan of the food standard and specifications of food, and then it mentioned that you've got to reevaluate the standard and specifications periodically, every 5 years, and then whatever you needed to do so is going to be prescribed by ordinance of the Prime Minister, which is this. There you can see that clearly the government has to conduct total diet study based on the intake data of a nutrition and dietary survey according to the National Health and Nutrition, Korean National Health and Nutrition Examination Survey. And also, because it was meant for the standard and specifications first, as a first priority, as you can see here, the heavy metals was the first priority, and mycotoxins as second, and third was organic pollutants, and fourth was pollutants produced during cooking, etc. So that's why we were able to start with heavy metals and mycotoxins for the first Korean total diet study, officially legally based. Meanwhile, we had to work on develop our guide manuals for sample preparation, which was published in 2016, and by next year we were able to develop and prepare a guidebook for Korean total diet study. And in there, what's included was guide for food intake survey of Koreans if we need any other survey, something like such as for infants or pregnant women, etc. And another one was guide for chemical analysis and quality control and quality assurance also. So these are the guidebooks published for QA and QC and chemical analysis in Korea, and these are used for the first Korean total diet study. And while we were working on intermittent total diet study in Korea, we were lucky enough to have very detailed food intake data from KNAs. However, because of the very detailed food intake data, the problem we were facing was the issue of too many not detected values coming up. And if we give them LOD for all ND values, we're going to end up having huge exposure or huge intake because LOD was big enough to give a big effect on like 200, 300 different food items. As you know, deterministic exposure estimation has been mostly used with a simple mean, body weight and simple mean, intake, etc., and also zero for NDs. But the R&D project I just explained between 2016 and 2013 and 2016, we had only one composite sample per food. It was used, of course, the kind of food was like 400 different kind of samples we had to prepare each year. But because of the one composite sample, and if you were working on 40 different kind of chemicals, you're going to end up with so many NDs anyway. So what we did was just using zero for NDs, and also we used individual dietary intake data. I mean, individual food intake data, such as everyone in Korea consumes like 50 to 60 different kinds of foods every day, and we had those data to merge with the contaminant content to drive the exposure data. And with that, what we could have was the kind of distribution of population intake or population exposure data to mimic probability estimation. And we found that WHO recommends to secure 30 to 50 analysis samples per food for hazard HM analysis with low detection rates for statistical treatment. And by the time we were working on this, US FDA was piloting with 24 samples for a 2-year period per food item from 2017. So based on all of this, and also some duty troubles we paid to US FDA CEFSAN. Actually, the first visit I paid to US FDA CEFSAN was like in 1996 to meet, I think, Dr. Jean Pennington. She was there at the time. She was responsible for total diet study at the time. And from that 1996 until 2016, we had maybe a dozen travels. We visited a dozen times. And then these pictures are from 2019. I believe you can recognize some familiar faces. And also I paid duty travels to Australia and also Netherlands, and to learn little by little from everybody. And the lesson was duty travel to BFR in 2017. And when we met them, we were amazed with their study design, because I was told that that was the very first total diet study in Germany. And we couldn't believe that they had such a thorough plan from the very first one, and I wondered what's going to happen next time. Anyway, I admired some of what they have, especially the total diet study kitchen. I really admired and adored it. We still don't have that kind of kitchen in Korea yet. Anyway, with all those informations we got so far, we were able to initiate the Korean total diet study, first legally based Korean total diet study from 2018, with a 5-year period to secure 30 individual samples for each food item. So each year we have been producing 6 samples, so adding up 5 years together makes 30. Based on WHO recommendation. And the objectives for this study was estimation of dietary exposure for heavy metals and mycotoxins, as I shown you before, through Korean TDS, and estimation of dietary intake for some nutrients for the first time, because before we had some experience of working on nutrients, but it was not covering a huge proportion of total diet. So it was not used so efficiently at the time, but now we are using this one to estimate dietary nutrient intake also. And everything was based on the guide manual for Korean total diet study. And also Korean government attempted to have stabilized planning and execution of TDS based on the representative and credible data such as dietary intake data from KN Heinz. This shows flow of the Korean total diet study from 2018 to 22. This study was composed of 3 sub-studies. Sub-study 1 was responsible for making food list, collection of food, and preparation of food, and for analysis, etc. And then the last step, exposure estimation. Sub-study 2 and 3 were responsible for the analysis of heavy metals and mycotoxins. And the representative food used in Korean total diet study was covering about 90% or more of Korean total population diet. And because the government specifically asked us to reflect change in diet continuously, we had to merge the data, food intake data from each year's KN Heinz as it comes available. And what we had to follow, another one was, for the whole period, we had to stick on that Korean KTDS guidebook, and we'd follow whatever is written there. And to explain about the representative food selection, for example, for the first year, we merged the intake data from 2013 through 2016, KN Heinz, and food list was made at the tertiary code level. Tertiary code is obviously primary code, secondary code, and tertiary code. Primary code is like apple. Secondary code, an apple with different kinds or different crops, whatever. And the secondary code would be raw apple versus dried apple, something like that. Third code would be apple, meaning it includes everything, dried ones and raw ones and the peeled ones and etc. Because the food list was made at tertiary food code level because it was the principles used for standard and specifications of food in Korea. And then, however, the food intake data collected in KN Heinz is differentiating between raw and dried and cooked or etc. So we had to make some kind of conversion in terms of amount to cover that difference in shape. And we had to cover at least 90% of total food intake. So we ended up 100 items at the tertiary food code level. And then we added some foods which is consumed very frequently but in very small amounts, such as black pepper or red pepper, something like that. So 7 items were added, ending to 107 items. And then we added more for mapping feasibility. And then another addition about with known high content of heavy metals and known high content of mycotoxins and etc. So we ended up with 130 items altogether, which covers 92.8% of total food intake. This is the raw data from the nutrition survey of KN Heinz. It is impossible to see anything, so I enlarged it a little bit, but you cannot read it because it's written in Korean, obviously. So I have translated only part of it. It is about the squash and tofu stew. And what you see under the column name of food are the ingredients foods used to make this squash and tofu stew. The subject number A1011001028 a certain day. And the last column is showing the amount of food ingredient he or she has eaten on that occasion. So with this kind of data, we were able to differentiate tofu in this squash and tofu stew was boiled, green peppers was boiled, something like that. So that's how we prepared the basic preparation method for a represented food based on the dietary intake data in KN Heinz. We were able to differentiate 33 different cooking methods. And then using that 33 different cooking method, we aligned the food and cooking method pair. And then selected the food and cooking method pairs with 10% or more or higher in ingredient amount and cap, not cup, cap 10% or higher in frequency of use, something like that. And then we thought that we needed to consider something more, which was cooking method used for foods of relatively higher intake or relatively higher contamination, something like that. So for that, we added 6 more ones, something like shown this, such as shown this. I think the heading on this table has been error. I think I'm going to fix it later. Okay, anyway. So we added 6 more for that, and we had to limit some number of preparation methods for those food with a lower amount of intake, and etc. So we ended up with 224 pairs of food and cooking method pairs starting from 130 food items. And for collecting food samples, we kind of divide the Korean peninsula as 3 regions, and 3 metropolitan cities were selected from each region based on the population size. And to secure 6 composites per year for each food item, 2 different combinations of cities were used. For those food with the seasonality, we had just 3 regions we used. So with 2 season samples, we're going to have 6 composites. But for processed food, which does not have any seasonality, we had to have another combination of 9 cities to make 6, which, as I shown here, the top left was northwestern region, and bottom is southwest region. On the right side is the east region, and 9 cities came to 3 regions together, and food to make 3 composites, and food were prepared for analysis. These are the list of cities and provinces in Korea, and for those with seasonality, we added Seoul, Incheon, and Suwon sample together. It make northeastern region composite, and Gwangju, Daejeon, and Cheongju sample together to make southwestern composite, and the other 3 for eastern composite, etc. But without seasonality, we had 6 city pools, Seoul, Incheon, Suwon, Busan, which has the highest population size, were going separately, and Daegu and Ulsan together, and the other 3 cities together. That's how it worked out. So how did we determine about the seasonality of the food products? Most of the fresh products in Korea are produced year-round in these days using greenhouse, etc. However, there are huge difference in terms of amount available at market. So based on that data, we were able to differentiate a bit different seasons. For garlic, May and June was 1 season, and November was another season. For crabs, female crabs are caught during the spring, and male crabs were caught during the fall only. So that's how we differentiated the seasonal samples. And these show you from the collection of the represented food. In each side, delivery to the central kitchen is done within a day because we are living in a very small land. It's about 1/3, smaller than 1/3 of this Germany. And then preparation was done within 2 to 3 days after the sample arrival. And I'm going to show you some pictures of it. First, we weighed all the utensils and equipments to be sure we monitor the weight change in samples. And then the preparation methods, 33 preparation methods are shown here. If we show you the wheat flour for baking, we pulled the flours to make a composite of wheat flour samples and made into and the kneading and making flat pieces and baked and pulverized. For pan frying method of flour, what we did was make batter and then pan fried and homogenized. And for mackerel, grilled mackerel, after we cleaned it, we pulled into a composite and grilled, and then bones were removed, and the weight of bones were kept to subtract from the sample weight from the beginning. And then for the boiled mackerel, we did same thing. Bone removal was done again, etc. After the homogenization of samples, cooked samples, we did make aliquots, and then it was packed and frozen at -20 degrees until the delivery to the analysis lab. These are the stored sample aliquots as of July 2022. We have quite amount of sample aliquots stored, and by end of this year, 2022, we're going to have another 6,000 aliquots. So these are analyzed in the first Korean TDS, heavy metals, mycotoxins, and some nutrients. And first, the analysis team had to work on with food matrices because, as you know, the food matrix gets changed during cooking, and which makes a big problem in analysis. So analysis team started to work with these 5 different kind of matrices, just differentiating low fat, high fat, solid, liquid, etc. However, they were still struggling with some problems in some analysis, so they had to work on and studying very much a lot and everything, and they finally used the guidelines for the validation of chemical method for the FDA FPM program, and ended up having revised representative food matrices to have right standard. It was low-fat solid rice porridge, tomato juice, peanut butter, olive oil, milk, and red pepper powder separately for spices and herbs. And validation of analysis method was done, including QA and QC. And this is an example, one example of calibration curve. As you can see, they're showing very good R-square values. And these are the limit of detection, ROD values for mycotoxins for each represented matrices. They were very low. And QA and QC and FAPA's preference testing also we participated. And then there we are about to estimate the intake or exposure. As you know, when you estimate exposure, you have to have very good quality of food intake data, and we are lucky to have that kind of data. So what we did was intake of amount of each ingredient food consumed by each individual. And we used the concentration of each chemicals in each individual food to have intake of chemicals. And then it was divided by individual's body weight to have the individual exposure. And because we have 7,000 individual data each year, when we merge the 3 years or 5 years intake data together, we are going to have about 30,000 individuals exposure distribution, meaning that we can have, if we wish, we can have age group difference, or you can have regional difference. It's up to you, whatever you want. Okay, this is one example of estimated exposure of heavy metals from the first year. We are showing the mean and standard error and the distribution of exposure through the population, Korean population. All the sampling weights and etc. were given in the calculation process. So it is representing Korean population's exposure. So the mean value corresponds to the value between 50th and 75th percentile. And these are the top 10 foods contributes to heavy metal exposure for each heavy metals. For lead, the sweet potato was the top source. For cadmium, rice was the top source. And if we talk about inorganic arsenic, only 4 rice product was good enough to make up 100% of inorganic arsenic exposure. It was same for methyl mercury also. Only 4 different kind of seafoods were enough to make 100%. And this is about the mycotoxin. The same way we show you mean and standard error and the distribution. But for mycotoxin, the mean values were not necessarily falling between 50th and 75th percentile. It was like this, depending on the detection rate. It was showing really different results. These are top 10 foods which contributes to mycotoxin exposure. And pears were the top source for aflatoxin B1. And kimchi was the top source for aflatoxin B2. And these are the estimated nutrient intake, which was done for the first time for iron, zinc, calcium, and vitamin D during the first and second year, I believe. And this shows you the mean, and this mean falls between 15th and 75th percentile as the case in heavy metals. And we tried to do the risk assessment in the second year. What we found was, the result from the 2019 Korean TDS was very, very much lower than what we had seen in 2016 official risk assessment report published by Mr. Food and Drug Administration at the time. So we were dealing with more reasonable, realistic data, and obviously MOE was low enough, I believe. High enough, I should say, and those percentage against the reference values were low enough. And it was done, same thing was done for mycotoxin also. Aflatoxins, B1, B2, G1, G2 together was not showing real good values, but still was much better than what was reported in 2016 risk assessment report. And we compared the risk assessment result by two ways of different kind of ND handling. One, a presenter approach using LB, MB, UV, and the other one was a hybrid approach using, depending on the record of detection before, either you use LB or MB, depending on the report. So using hybrid approach, we were able to produce the much lower MB values than the traditional ones, as you can see here, and also UV values. These are the comparison of food composition table based comparison with food composition table-based estimation. I believe you've heard about it yesterday through the poster presentation. And calcium was quite comparable, but not the iron, because the huge difference between iron intake estimated was due to the error in food composition table, not in total data study. Mr. Food and Agriculture didn't like to see this. They were not happy with this, but it was a fact. And the sodium, they were comparable. Potassium was comparable, except that there was huge difference in terms of potassium content in coffee product. And these are the estimated exposures to hazardous materials or nutrient with or without mapping. As you can see in the last column on the right side, you can see that by introducing mapping technique, usually you get 20 to 30% higher in result. And this slide shows you the NDs, not detects for heavy metals by food group from the 4-year studies together, 24 samples for each food item. As you can see here, for aluminum, we have only 5.9% NDs altogether, but for lead, about 60% of the values had NDs. For mycotoxins, it's not NDs, it's detects, number of detects, because most of them were NDs anyway. So Zearalenone on the right side, the last column, was the one with highest detection rate, I would say, with 9%. And the result I'm going to show you is very tentative, because our 5-year study is not completed yet, but we hurried to just give you some numbers today. So we had to use the values which was not completely validated yet. So I denoted as tentative KTDS result from the 5-year study. And as you can see here, the mean and 95th percentile based on the population dietary intake is much lower than what was reported in 2016 risk assessment report. And it's comparable among those 5-year period data. And same thing is shown here for mycotoxins. Also, 5-year data, 5-year result was much more stable than the 2016 report. And then these are the kind of a risk assessment, preliminary risk assessment exposure to mycotoxins. As you can see here, the MOE for aflatoxins, we are seeing the 5,500 for mean and 1,500 for 95th percentile, something like that. It's not great, but it's not that bad. I think it's much better than before, the result we were seeing before. However, if we see the right side column, the US, based on US FDA hybrid approach, we see that middle bound values are much lower, maybe 1/3 of what we used to have on left side. So we are thinking about using or adopting this US FDA hybrid method to handle NDAs for our data. These are just some examples of what we have seen in terms of heavy metal content between different regions and different seasons. 3 regions, as I explained before, Northwest, Southwest, and East. And the left side is the first season each year, right side is the second season. Second season is actually the fresh one on that year, because harvest season is usually fall in Korea. And the former one is the kind of older one from the previous year. And as you can see, there are not much difference in terms of any constant difference in terms of different seasons. It goes up and down, and we cannot tell that there is any kind of significant trend, except that there are clear differences in terms of regions of collection. So we need to keep that regional collection, I guess, in place. And it was about the same for aluminum and arsenic. And this shows you about the heavy metal content in Napa cabbage, which is used in making kimchi, Korean kimchi. It's the same for the case of rice. We don't see the difference between seasons, but we see the difference among different regions. And this is about the red pepper powder, which is used in making kimchi again. It's the same for the rice or Napa cabbage. And this is about the aflatoxin B1. In addition to the heavy metals, aflatoxin B1 also shows no consistent difference between 2 seasons, but clear difference among different regions. So I'm showing some results about the papers we published about nutrient intake, which has never been there for something like for iodine. It's never been tried before. And then some papers published about analytical method and also about the validation of method, etc. There are tons of different papers, of course. And this is supposed to be the last slide, and this is supposed to be the best important slide, but I'm not sure if it is good enough. First, the first Korean total data study will be completed by the end of this year, and hopefully we will have a better, stable result by that time. And the second Korean total study will be resumed from next spring. Korean Ministry of Food and Drug Safety was able to secure the budget for the second term. So we're going to go for another 5 years. And although the act was amended in the Food Sanitation Act, that's why we had to go with the standard and specifications, and that's the reason why we had to start with heavy metals and mycotoxins. But behind the scene, the Minister of Food and Drug Safety is planning to add other kind of analytes, one by one, little by little, quietly. So hopefully it continues go on. And if we have any idea or suggestions of utilizing the stored samples I showed you before, like 3,000 aliquots, they're more than welcome. Thank you for your listening.